So let's see if we can get through chapter 6 in about 6 minutes here. Chapter 6 was our big formula chapter where we did a lot of plug and chug off of our formulas. Here's our 4 major topics: inverses, identities, the double, half, sum, difference formulas, and then lastly the trig equations. So first thing here is the inverses. Here's your basic definition of those. So we've done all 6 trig functions of angles equals a value: 1/2, square root of 3 over 2, 0, undefined, whatever. Inverses ask you to do, so basically, where is the sign a certain value? So you're doing inverse of a value equals an angle. So inverses, you're always finding angles. Okay, so you can kind of think where something's happening. So first thing is, where are all our inverses set up here? Everything in quadrant 1, obviously, we want 1 positive and 1 negative of each. So that means inverse cosines are back here because the x's are negative. So then also inverse secants. Inverse sines are down here because sines are positive in quadrant 2, so we don't want that. That means inverse cosecants are also down here. The only ones you really have to remember are tangent and cotangent. So off to the side is a tangent graph. So you can see we're going from negative pi over 2 up through pi over 2. And then this here is a cotangent graph. Cotangent's over here. Okay, we said the C and the C go together, cosine and cotangent there. When you're doing them in your calculator, make sure you end up in the right quadrant with them. Identities. I'm really not putting an example in here. Look through section 6.3. The back walks you through a bunch of them. I'll only give you, some guidelines to doing these here. Okay, look for common denominators, substitution of identities, writing everything in sine and cosine. Make sure you stay on opposite sides of the equal signs. You can't be going across those things, but you're trying to turn one side into the other. Okay. Next are some difference formulas here. So these are all on your yellow sheet. We just have to be able to use them. So if we want to get to cosine of 105, we know what 30, 45, and 60s are, and also any multiples of those. So you can get to 105 by adding 60 plus 45. We could also do, like a subtraction, 150 minus 45. You just take your formula, plug in your values there, and make sure you watch your signs if you end up in a different quadrant. Sum and difference also has 2 for tangent here. Again, same idea. You want to do tangent of 105 again, or 305, anything like that. Okay, you can add or subtract values that we know, and we just plug those in. Okay, double angle formulas. Here's all of them here. For cosine, you have 3 choices. It's really up to you. They'll all give you the same thing. You get 1 for tangent, you have 1 for sine. Here's an example of a double angle. So I'll tell you the sine is a value, and I'll tell you a quadrant. So you need to get a picture here, and then they want you to do sine of 2 theta, cosine 2 theta. Once you have your picture and your triangle completed, all you have to do is go plug stuff in. So sine of 2 theta is this equation here. We see what happens. Cosine of 2 theta, I use this equation. You use any of the other ones to get the exact same numbers as well. Half angles, these are the ones we have to be a little bit careful with. We use these to get things like 15 degrees, like 22.5. So if I want to get to tangent of 22.5, it's the same thing as 45 divided by 2. So clearly I'm going to use this equation here. Now when you go plug things in, this alpha here is going to be 45 degrees. You don't want to plug in the 22.5 because we have no idea what that is. Okay, so we plug those values in. We would take the positive sign there because 22.5 is in first quadrant. One thing with the half angles here is this kind of problem. So I'm telling you a cosecant and I'm telling you a quadrant, and then I want you to do a half angle. The one thing you got to watch out with half angles is where you get your positive negative sign. So if I know here's where alpha is, if I have to do a theta over 2 or alpha over 2, make sure you divide all of these by 2. So alpha is in quadrant 3, you divide these by 2. Alpha is now in quadrant 2. That means if I'm doing a sine, it's going to be positive. So I'm going to take the positive value there. If I'm doing a cosine, quadrant 2s are negative. So I'm going to take that there. If I'm doing a tangent, they're negative as well. So I'm going to take that value there. Okay. And again, this alpha, in this case, it doesn't matter what it is because we have the triangle here. These types of problems caused you guys some issues here. So if you see something like this, it's a cosine 2. This is an inverse. So inverses are really just asking for angles. So rewrite it as a theta, cosine of 2 theta. Draw your triangle in the appropriate quadrant. Pick any one of the formulas you want. I picked the second one and plug those in and see what happens. Trig equations. So they can come in a bunch of different ways. One of them is we just pretend these are x's and we factor the quadratic as usual. So we factor it, we solve each of these. So cosine theta equals 1/2. Where does that happen? Well, two different places, pi over 3, 5 pi over 3. Where's the cosine equal -1? Only at one place. You plug these values in your calculator and in radian mode, and you should get zeros. Other way these can happen are something like this. So 2 sine of a big blob equals a value. Okay, so here's kind of our steps we want to go through. So we just pretend this entire thing in here is just one big blob. We go ahead and we solve it for sine. So where's the sine equal these values here? Sine's negative in those two quadrants. We set up the appropriate triangles, we figure out the reference angles, and then we adjust them. So I did them in radians here. You can easily do them in degrees if you wanted. It happens at 4 pi and also at 5 pi over 3. So once you've found where the sine of the blobs equal the values, you can go plug that blob back in. So 3 theta minus pi over 2 equals this. You put the 2 pi k in because I want everything from 0 to 6 pi. So we say blob equals the value, and then we just go ahead and we solve for theta. Same idea over here. Blob equals 5 pi over 3 plus every 2 pi k, because every time it spins back around, we solve for thetas. So these are the equations. Now I want everything from 0 to 6 pi, so start with a k equals 0, because these will go away. So your first two answers are 11 pi over 18, 13 pi over 18. Start adding 2 pi's to all of these until you get up through 6 pi. So that was chapter 6 in 8 minutes.